good morning, good afternoon, or good evening. Depend on where you are located. So this is my third presentation for 2015 Australia New Zealand webinar by the APAC OUC meeting. This presentation is going to discuss how we can leverage Oracle database in-memory option to accelerate some of our business applications, including Oracle business application. So before this presentation, I already gave two different topic presentation in last month. The first one was was about Oracle Cloud for Oracle DBA. The second one was about Oracle database 12CR2 upgrade. So those two applications are really posted in my website, in my blog. So here is my blog. Under presentation, I list all the presentation I did in last 10 years. The top one, the post presentation was 149, 148. Those were the presentation that I gave to this webinar. So you can come here to download the slide, or you can come to this link, that is a YouTube link, to get a live stream of a presentation. So let's go back to this presentation about Oracle in-memory. So just a little bit introduction about myself for those people who have not attended my previous presentation. So I'm the technical staff and the lead engineer in Oracle EMC database engineering team. So I've been working on the IT industry for 25 plus years. My interest area including Oracle database, cloud, and virtualization. So I've been doing some presentation. You probably already saw that in my blog. I have about 150 sessions in last 10 years. So I also wrote some articles, including the book, Oracle Record book, which was published in 2013. So I've been very honored to be a member of Oracle ACE Director Committee since 2010. And I also received a few award recognition from industry as well as Oracle magazine. So most useful information is about my blog. So I put some of our Oracle related discussion in my blog, as well as all the presentation I did, and also all the white paper I wrote in last 10 years, including some of the published, all the 35 article was published in different sources. Some of them published in the academic magazines such as IEEE, IEEE Big Data, IEEE High Performance Computing, as well as the Dell Power Solution magazine and IOG Select magazine. So my current role in Dell EMC is the lead engineer for the Dell EMC Oracle Solution Engineering. So my responsibility was to my team responsibility was to develop or validate Oracle database solution stack based on Dell EMC infrastructure. Here is the picture showed all the component of this infrastructure. That's pretty much the entire stack that support most advanced Oracle database solution, including the rack or cloud solution. So you can see underneath, starting with the storage, we have all the most powerful storage, and also the network device, and also the server. Some of advanced servers such as Dell 14G server. We also support multiple operating systems, including virtualization, Oracle VM, and VMware. And on top of that, we support Oracle database, we are supporting the 12CR2. So as part of offering, this stack has been validated to form the product called or a ready bundle. So this ready bundle is test and validate entire stack to run Oracle database that consists of entire from all way to storage to application. So as we just discussed, we include some of our advanced infrastructure, such as EMC storage, Dell EMC storage, VMAX Extreme IO, those are advanced storage, and also Dell networking, and as well as some Brocade 5-channel networking, and including the Dell EMC, Dell latest enterprise level server, such as 14G server, R740, R940. We validated multiple operating system, and we produced the validated solution as well as some toolkit that simplified the deployment of Oracle solution on this infrastructure. We also supported multiple different workload type, such as OLAP, OLTP, and mixed workload. So you can come to this link to get all the validated information. The validated information published in Dell website as well as the Oracle website. Okay, let's come back to our topic. So in today's presentation, we're going to cover several topics. We're starting with the introduction about InMemory database in 12CR1. We're also going to discuss some of new features introduced in 12CR2. Then we will show how to leverage this new feature in the real IT environment. We also discuss how to leverage this InMemory Advisor to better utilize this new feature. We're also going to share some of our experience using this new feature for business analytical application. So let's start with the first topic. Let's discuss what is the InMemory option, what is the architecture looks like, how to use that. So Oracle 12CR1 introduced this InMemory option. The purpose of the InMemory option is mainly to accelerate analytical query with big performance boost, but they also try to help to some missed workloads, such as the database that run both OLTP and OLAP. The performance improvement for OLTP database was kind of indirect for direct improvement for OLAP. So how they improve for OLAP application? The direction was to remove some of the index that was for OLAP application, so that when we run application on OLTP, the OLTP application doesn't have to rebuild those index that was built for analytical application. Why? Because we have this in-memory option, so that the application running business analytical application doesn't require those index anymore. They can get data directly from in-memory, which is much faster than going through the index. So those index can be removed as a result. As a result of removing index, this will dramatically improve the OLAP application. The third design purpose was to be transparent. So Oracle query optimizer should be is smart enough to pick up the in-memory option. So for those query that is most suitable to run from in-memory, the query optimizer will change the query plan so that the query will run against the in-memory instead of the buffer cache. Now we introduce this in-memory option. So as we show that when Oracle introduced this in-memory option, they kind of adapted this dual format memory architecture. It still keeps traditional role-based buffer cache. This is designed for OLTP application. This will allow us to get a very efficient OLTP insert update operation. But at the same time, Oracle introduced this in-memory option as a second piece of the memory buffer memory in SGA. The name of this memory is called InMemory column store. This is specifically designed for query, big analytic query. The difference between these two memory buffer is in memory option. They are in different column format instead of store data by row format, which is in the buffer cache. You can see the red line in buffer cache is column based, but in memory option they use row based. And another difference is the data stored in the in-memory can be compressed. This will dramatically improve the performance because when you query data, if the data is compressed, you can actually get data much faster with the same amount of time. So how to use this? First, you have to figure out. You have to provide the in-memory. So it's a single statement. Auto system set in-memory size will define this in-memory column store by giving them the size. But just keep in mind that when you said that you want to use a 100 gig memory, make sure 100 gig in-memory, make sure you have that additional physical memory. This is not going to be on a swap because that will defeat the purpose. So this in-memory has to be physical RAM. So when you provide this statement, you can start up a database, and this basically will show how much in-memory size. So when you configure the in-memory, so basically Oracle will allocate two pool for the in-memory, and this actually shows how the in-memory works with 12C R1, the pluggable database. In each PDB, there are two pools that is allocated to store data. The first pool is to store the metadata. The second pool is to actually store the real data. But each PDB has two pools. So by querying the in-memory underscore area, you will see how much you allocate. But in 12CR1, each PDB is actually shared the same pool. There's no boundary to specify each pool how much they can use for in-memory area. But this will be changed in 12CR2. In 12CR2, you actually can set the quota for each PDB. So once you allocate the in-memory area, you can start thinking about how to load your database object, such as table, into the column store. There's a couple ways to do that. You can specify that. You can directly set it on table level. You can specify which table needs to be loaded into the in-memory. You also can set it on table space level, which means if you set this in a table space level, all the table in this table space will be loaded into in-memory. There's another very useful is you can set in materials review. So when you set a materials review, then this materials view will be automatically loaded into the in-memory. So next time when you query this materials view, this query will not get data from disk. They're going to get data from the in-memory. This is extremely useful for business analytical application because a lot of application use materials view. And but you also can specify priority because chances are you want to load many tables in the in-memory, but your in-memory resource can be very limited. So you probably want to give a priority. So you can set a priority for table level from low to critical, none to critical. None means you're not going to load it. Critical is most critical. If you set a critical, when you start up a database, this table will be automatically loading in memory. And you also can specify the compression as we discussed. When your table loading in memory, the table can be compressed. So you can specify different option for compression. Some of compression is to save the space. Some compression option is to optimize the query. So there's a couple options you can specify. So this auto table statement basically specify compression, also specify priority. So when you turn on this in-memory option, Oracle, each of these Oracle instances will have this set up for background process. Those background process will handle all the necessary operations that keep this in-memory option, including the keep data sync between your buffer cache and in-memory. Because if you're running a mixed data workload, the chances are you may have an Oracle OLTP application running against the buffer cache that could bring some new fresh data. So Oracle background process will automatically synchronize the two buffer cache, two memory area, so that the data in memory will get almost the same piece of data, same kind of data as the buffer cache. But you'll expect some delay if you have a very heavy OLTP application running on your database. So the recommendation is you can have mixed workload, but don't put a too heavy OLTP application on the buffer cache. Otherwise, you will see some delay. So when you load the data, when you run this auto table in-memory statement, this statement will automatically kick off the data loading process. But the behavior is this statement will immediately return them. But this statement just kick off the loading process. That doesn't mean when you finish this statement, the data is already loaded. Because the data loading could be a long process. When you kick off this, the background loading is run from behind the scene. So you can check the status of the data loading. This is the statement that you can use to check the data loading process. And this show, I put this SQL statement in this SQL script. The SQL script basically will check how much data has been loaded. So data GB is actually how much actual data in the disk. And the in-memory GB basically show how much data has been loaded so far. And the third column is a percentage. The fourth column is compression ratio. So from here you can see all 5 table has been loaded because the load percentage 100%, and I can tell the compression ratio. You can see the data size in memory is much smaller than the data size in the disk, thanks to the compression ratio. So I actually tested in my test environment. I load about just over one terabyte data, original size in disk, and when we load in memory, we only got 246 gig. This ratio can be varied depending on what kind of compression you use and what kind of data. If you have a lot of non-value in the column, you could have some high compression ratio. But anyway, this is example. To load that much data, it took about 4 hours. But this is also depends on your environment, especially what kind of storage you use for your database. So because this data loading process essentially is going to the disk to get all of the data put into memory. So that could be huge I/O intensive. If you have a slow storage, it could take much longer. But in this case, I'm using OSSD, so to load much data. So if you use a traditional hard disk, this could be 10 hours, even higher. And sometimes we found that if we just use this auto table statement, sometimes they won't load 100%. They load 99.97% and stop. So the one solution is run some kind of full table scan query against those tables, such as this one, select count from this table. This will make sure that you get 100% data load. But if you just leave this 99.97% there could be some consequence. Let's talk about this consequence. I will talk about this consequence later on. So once you have loaded this data, then you should be able to take advantage of this in-memory. So Oracle not only allow you to put the data in memory, they also have I built some kind of several query plan to accelerate your query execution. Those are some of query plan: in-memory scan, in-memory storage index scan, and SIMD vector processing, in-memory join, in-memory aggregation. Those are the query plan. Query optimizer is smart enough to use, so you don't necessarily have to put it in your query. If you know this very well, you can put a hint. Otherwise, you just don't need to do anything. You just write your query as you wrote before, and query optimizer should be smart enough to figure out how to leverage those options to accelerate your query execution. So that's why we call it application transparent. You don't need to modify your current application. The query optimizer will handle that. But one thing you want to make sure that actually, after you load the data in memory, you can check it, make sure your query is taking advantage of this in-memory option. One way you can do that is actually check query plan, just a regular check query plan. This query plan will show this keyword called in-memory full table, such as in-memory full table, so this basically indicates this query is doing the full table scan, but it's on in-memory. So in-memory full table scan can be much faster than your index scan on disk. So that's why we can get rid of those index that was originally built for the query, the analytic query. So let's move to second topic: how does in-memory work with rack? I want to share some of our experience. So the behavior of the rack is, as we know, the rack you run multiple nodes. You could have a single node rack, but more common way is we have multiple node instance. In a typical case, we have two node rack, which means you can run a query against both node or each single node. But the behavior one you see in memory is by default. The if you issue statements I want to load this old table into the database, by default the behavior is this object, this old table will load 50% the row into will even distribute across rack node. If for two node case, this table will have 50% data loaded into in-memory in instance 1, another 50% data loaded in in-memory 2. For non-exit data, non-engineered system, you cannot load 100% into both instances. So they will by default it's just load 50%. But this was duplicated distribution is only available engineered system. So how let's see what is going to impact. So if you shut down for two node case, if you shut down one node, yeah, you should be able to load this table in 100% in this case. If you shut down instance 2, then the behavior is all the table can be loaded 100% into instance 1. But if you have both system up, both instances up, for PDB case, if this PDB is open on one instance and not open in other instance, then if you load a table of this PDB in the memory, 100% table will be loaded in instance 1. But if you have a PDB open on multiple instances, the table on this PDB will be even distributed to the in-memory column store in multiple instances. This is just an example. It's around 50%, but not exactly. Sometimes it may not be 50%. So you can see this. I actually run this script on multiple node. This is actually how much they show when we finish the data loading. This actually show how much data they actually load. So what's the consequence? If we have a two node case, I load the data into two node, what's the consequence? So if we just check a query plan, it show the query plan will use in-memory 4. In this case, it indicated the query is using in-memory. And even for most complex query, it's the same way. So they are using the in-memory option. But then I was actually doing some comparison. I found that if you load a table into two node, I found that actually the query actually was the performance was very bad. And this is just an example to show that. So this is just an example to show that on single node, this query only took about 10 minutes to finish. But if I run a single query on two node case, it took about over 20 minutes to finish. It's twice the time to run a query on two node and then single node. That should not be the case. Why? Then after more research, I found that for a two node case, there's a huge I/O weight. So for single node, they only got a 1.9% I/O weight. But on two node case, they actually got 58% I/O weight. So why? Then what we found was actually when query run against the in-memory, because each table only got 50% data loaded into in-memory in each instance. When query hit that instance, they have to go to because most query is full table scan, which means they have to scan all the row. So because it only has 50% of data loaded in memory, so they have to go to the disk to get another 50% data if this was for two-node case. So that's why we have a huge I/O wait, because they need to go to disk to get data. But for single node case, because we were able to load 100% data in memory, so simply there's no I/O wait. So that's why the performance on single node is much better than two node. So next time, just be aware of that. If you want to get a high performance, make sure you load everything into single node by shut down second node. Or for PDB case, you can keep both instances up, but you just open one PDB just open this PDB on one node. So in this case, your query will just run then your table will be loaded in the first node 100%. Then your query will take advantage of InMemory. Another lesson learned we got was during our test was we run the same query on this parts supply table on we did a comparison on two databases, exactly same schema, exactly same data. But what we found was the same query on the same table running on database 1 was much slower than database 2. Why? We loaded this table in InMemory for both database. So that should not be the problem. Because we want to use the query, we want this query to take advantage of this InMemory. But how come the query on database 1 is much slower than the query on database 2? Then we went to AWR report to figure out why. So what we found was the logic I/O on database 1 was much higher than the database 2, 62 times higher on this specific index. And the even worse for physical I/O is about 2,700 times physical I/O in database 1 than database 2 for this particular index. So why the query will take advantage of index when need to use the index? Because we want this query run against the in-memory. We actually don't need this index. By the way, this index cannot be dropped because this is the primary key index. So the index has to be there. But the important thing is the query should not use index. They should directly go to the in-memory account store to get data. So then we took a look at how the in-memory in-memory was used by taking a look at the in-memory segment by scan option section, which is also part of AWR report. What we found was on DB1, the query does not use this in-memory object at all for this table. So you can look at the DB1. This basically lists all the in-memory segment scanned by the query. There's no parts supply table. But on DB1, it shows the parts supply table in-memory segment was used about 69,000 times. But for DB1, it was none. So pretty much we conclude that the query did not take advantage of in-memory for DB1. Instead, they actually use the index and go into disk. That explains why the performance on DB1 was so much worse than DB2. Then we want to ask why. Because we loaded this table into in-memory on both databases. Why there's so big difference? Then we double checked, look and see what's the situation about the loading process. Then we went to database 1. What we found was this parts supply table. They only loaded 99.73%, almost there, but not quite yet. They missed about 0.27% the data. It's just because this 2.7 data that is not part of a non-loading, then the query actually just give up uh, the data loading, give up the in-memory scan. They strictly directly went to the index scan. So the lesson learned is this number is not very good. So make sure you get 100%. So the solution was we run this simple query, select count star from this part table to do full table scan. After you run this query, we got 100% loaded. This number changed to 100%. Then we run a query, and we got actually same performance on both database. So lesson learned is always check after you finish the data loading. Always check, make sure you got 100%. If it's not, run this select statement, full table scan statement. This will ensure that all the data will be loaded into in-memory by 100%. Okay, that's some of lesson learned. Let's change it to another topic. It's new feature, 12CR2 new feature. So this slide showed all the summary of the all the new feature introduced in 12CR2 for in-memory database. First one is dynamic sizing. They can dynamic size your in-memory column store. There's a couple of after that, there's in-memory compression. This is a feature that will accelerate your design. Is designed to accelerate your specific query. We'll talk about it a little more. And there's a couple more options. You can specify object level support for service. You also allow this 12CR2 also allow you to build a column store in active data guard. In 12CR1, you only can build this in-memory store in primary database. You won't be able to build this on the standby database, but which we know that it's quite often that we use the active data guard to run the report. So definitely is great feature that allow us to use the in-memory column store in active data guard to speed up your query on the standby database. And there's another the ADO support for column store. This is also very useful because this allow you to inject some object which is already in column store. But if you found those object has not been used frequently, you can write an ADO policy to inject this object, so you can free out some of memory capacity for most frequent used object. So the heat map actually keep tracking the usage of this object in the in-memory. The last one was a join group. This is also very useful if you do full table. If you run some query in join operation. So we'll discuss a little bit more detail in next slide. So the next few slides basically get a little bit more deep discussion about this new feature. The first one is you allow this CR2 allow you to adjust the in-memory size without rebooting the database instance. So the single statement you can do both. You can do this, but this was not possible for 12CR1. Then there are the in-memory option. This option allow you to take advantage of the in-memory for queries such like this, like select price times text ratio from sales. Previously in 12CR1, the in-memory store you will have a two column, text column and a price column. But when you run a query, you still have to do the calculation. But 12CR1 in 12CR2, it will allow you to store the value of this expression in addition to the each individual column. So what happens is when you run a query, the query will not go to the price this column get the data, then do calculation. Instead, they're going to get the value the value of this expression directly from in-memory because the value of this expression is stored in the in-memory. So your query can take advantage of that. This can be this can reduce significantly on those computer expression, uh, save a lot of time. So we're translating to a very good performance. So in this case, the price this expression is not complicated. But if you have a case that you run very complicated mathematical expression, this could further reduce your time that you need to do this calculation during the query operation. So the most important thing is uh, Oracle will automatically recognize this once they see you have this kind of expression uh, frequently used. You don't have to say anything. You just run this query. Oracle will automatically store those data store this expression data into in-memory, such as this. So you have this very complex value. If it's a frequent used, computer intensive, Oracle will figure out automatically detect it and populate this. But you also can disable that if you don't want it. But that was the automatic way. But if you feel like some of the expression you also want to specify by yourself, uh, you could do that. This is called a virtual column. So you actually can specifically tell Oracle that I want to create this virtual column for this expression. So as a result, the in-memory store, they're going to create this column and they're going to store the data of this expression into this column. So next time when you run a query, such as this, price times this expression, Oracle, your query will automatically come to this virtual column, pick up data instead of redo the calculation. The idea is very similar to the expression, in-memory expression. The difference is you can manually set this. So the next important option is called a join group, which is also very useful. This is designed to speed up some of join operation. As we know that the most frequently the table stored in in-memory store has been compressed. So if you want to join those two tables, such as item table and a path table using this join key, then every time when you join this table, Oracle needs to decompress the join key column, and they do the join operation, which can be very time consuming because the decompression is take time, and especially if you have a huge number of rows, they have to decompress every value and do a join operation. So instead, in 12CR2, they introduced the join group concept. If you know these two tables will be joined by this key, you can create this called join group statement. This statement will tell Oracle that I will do this join later on. So what Oracle will do is they're going to compress this table, these two tables, but they're going to use the exactly same hash algorithm for this two table, so that later on when you want to do the table join on this two key, Oracle doesn't have to uncompress the value. They directly use compressed data to do comparison. So basically skip the compression operation. So this could significantly improve performance. So here's some example I show for this simple query. Without join group, around almost almost 6 minutes, but with join group around about 4 minutes. So that's save about the 30% of the time. Okay, so those are some new features we in 12CR1 and 12CR2. So let's talk about how in your IT department how you want to use that. So as we discussed, your memories can be very expensive, but your most likely your reporting database can be huge. So chances are you only can load a partial sum of table. You're not going to be able to load all the table. Uh, so how are you going to select it? Firstly, how are you going to decide how much in-memory you need it? Second is how you going to pick those table, which table need to be loaded into in-memory. So Oracle has this called InMemory Advisor tool that you can use. What happens is this InMemory Advisor tool can come into your database to do some analytical analyze based on your previous query statistics and give you the recommendation. So the recommendation include how much in-memory you need to use, and they're also going to tell you if you use such a number of gig memory, you can get a number how much x times performance improvement. So as we discussed, how do it work? Because in-memory will collect your 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 previous activity through the single plan based on the single plan, and also active session, and also how the parallel query run and other statistics. All those dynamic statistics that use database store for your query will be used by this in-memory advisor. Then they give you this recommendation. The idea is that they're going to try to achieve what they are trying to achieve is the maximum reduce the I/O, reduce the cluster transfer rate and the buffer cache weight, and further improve performance. So how to do that? So just basically Oracle has this two white paper. This two white paper show you how to get this tool, how to use that. This white paper has been updated for 12CR2. First introduced on February 2015. That was 12CR1. So you can download this direct load into your database server, and you can just simply use SQL Plus to install this advisor tool. There's a couple of DBA options you have to grant it, as DBA should be able to follow that. Then once you have the advisor installed, you can come here to use that. So the way to use that is you run your application without in-memory for quite a period of time. So if you know that you have a heavy reporting, like for example from 8 o'clock in the morning to 9 o'clock in the morning, the 1 hour. So what you can do is you just run your query, just a normal query during the time frame from 8 to 9. Then Oracle will record all the dynamic performance data in the database. Then after 9 o'clock, you can run this in-memory advisor script or package. Then by giving them the time frame that you want to use to analyze. In this case, I give you 60 minutes. I point out 9 o'clock to 10 o'clock. This guy has used 9:33 to 10:33, 1 hour time period. If we know that this is the most heavy business analytical report time. So then this advisor tool will collect all performance information during those period of time to do some analysis. They have some built-in intelligent algorithm to do some analysis. Then they figure out what's the best way to leverage the in-memory option. So once we finish that, they're going to produce two reports. One report show you how much in-memory you should use by giving different recommendation. So in this case, I was running very small operation, so it's only 43 gig. but in your big database, it could be bigger. But this just show you the actually the how the analyzed report looks like. And then they also gonna, this is how much InMemory you need to use. The second report show you which object, the top object, need to place in memory, and also what compression option you need, and also estimate the benefit. So this is another session to show you. You can tell that they're gonna tell this district table has most advanced benefit if you can put it into the memory. Okay, so let's change to another subject. So to share some experience, I use InMemory for OBIE, some OBIE application. So I was doing some research to work with our IT department to see how we can use InMemory to speed up some of our current some BI application. So they are at that time they were using OBIE 11G. There were a couple of dashboard report, an ad hoc report. So specifically, this is just introduction. For typical BI environment, they have a presentation layer, and a business model mapping layer, and a physical layer. Physical layer normally is about a table or view, So, but presentation layer is really the report. So normally when they run a slow report, the business user will tell you, yeah, my such as report was running slow. Then they ask the BI element to take a look at it. The BI element will figure out the mapping, then eventually fall into the physical report. And this could point to the exact table. So in this case, I did some analysis on this specific EDI report. I used this EDI report to map into the physical layer. So that was the idea. Started with a business report and find out some business very expensive storage I/O operation. Then we figure out how to reduce those I/O operation by using InMemory. So in this case, I'm starting with the EDI report and found this. Specifically, this is a fact EDIQ. This is actually one of the report. I'm pointing to through this mapping. I'm sure I found out that this report depends on this fact EDIQ V factor, fact EDIQ V view. The reason the report was slow was because the query on this view was quite slow. Then after digging how this view was built, I've seen the 4 underneath table, and then we decided in order to improve this report, we can try to load this 4 table into InMemory. That's what I did. So I just run this simple statement and load in InMemory. Then we can check how much they use. So just be aware that at that time I was using just 1 month's data. I didn't get a whole lot of bigger. This could be several years data, but I just used 1 month's data to test it. So this showed the InMemory size. Then I did a comparison on the query on this view. So this show without InMemory, they just use all 4 table scan on this 4 table. But with InMemory, they did an InMemory for table scan. Then I did a performance comparison. I found that with InMemory, we actually save about 40% of time. So that is for this case. As we know that, as we just discussed, this is 1 month's data. And if I had about a year's data, then InMemory operation, this time, if I have a 10x amount of data, the time for InMemory probably doesn't change much because InMemory is very fast. But if I have 10x amount of data for non-InMemory, potentially I could have 10x time. Instead of 4 minutes, I can get 40 minutes. then you can see more difference. So this probably go to 3-4 minutes, 5 minutes, but this can get 40 minutes. So that the gap between these two will be much larger if we have years data or several years data. And the report also, when we run the actual dash report, it also showed the difference. And the difference for this 1 month data is 2 minutes, about a little bit over less than 2 minutes. But if this was for much bigger data set, the 9 minutes could be 50 minutes or 1 hour. But your in-memory probably doesn't grow much, maybe 10 minutes. So you will compare with 1 hour over 10 minutes for a large amount of data. Okay, so we also did some performance benchmark. Use this using this in-memory. So we run a TPCH like a performance benchmark on this kind of setting. So I was using the storage was based on the SSD storage. So we did a comparison. So if a database was on the traditional storage, and database was on the SSD storage, the table was on traditional storage, table was on the SSD storage, and table was loading in memory. So this actually showed performance improvement. So we have two different performance characteristic. One is called total queries time. So I have one set of query which consists of 20 queries, and this record how much time it took to finish this one set of query. This is one criteria. Second criteria is by hour how many query we can finish. So this is kind of a query runtime. So for 21 query, how much time it took? This is for a fixed number of time, how much query they can run. So it shows some performance gain. Okay, so let's get into the last session. In last session, I want to show you two kind of experience I learned during our some additional business analytical study. I want to show you how InMemory DB can or cannot help those applications. So one of the query was we're using this called a static analytical application. What this application does is they're gonna first, when I start up this application, they're gonna go to the database to query the big data set. This data set is a 100 million row data set, and with 32 columns. So the behavior of this is they're not going to run a query. They just go to the database, fetch all the data, and copy that into application server. So first thing we want to see is if for this kind of application can in-memory help. So what we found was there was not much help, and actually the almost the same time, not much help. Then we have to figure out why. So it showed that no physical read. That not in memory, they have huge physical read. That means our table is loaded in the in-memory, but why the query time doesn't change? Then what we found was actually the most of the time spent for this query are not in the query to the table. It's actually the time they spend on SQL Lab. Because for that 100 million row times 32 seconds, that much data, they need a copy from database server to application server through SQL Lab. This is a huge SQL Lab transfer. The most of the time is spent on the networking part. And the time to spend on database query is insignificant. So that's why we don't see any difference at all. So that lesson learned tell us that if you have this kind of a business analytical application, the in-memory will not help you. The most frequent, most advanced query is if your application go to a database, query huge set of data, but they only return a small set of result. That's the query that you can take the most advantage from in-memory database. Not this type. This type is you return huge amount of data set. You basically copy everything from table to database to your application side. Then this will not help you. The second example is we have this application that will do aggregation and computational. Specifically, we want to calculate the standard deviation. So what standard deviation does is you get an average. Let's say if you have an average salary, so whole company average salary, you get an average. Then they also kind of count each individual employee, how much deviation between their salary and the average salary. Then we kind of average them together. So that's called standard deviation. So what we found was when we use the in-memory option, standard deviation doesn't help. But for summary average, you can see the several computations, summary average, and also average count. Those top three are actually get a significant performance improvement, but not standard deviation and the average deviation, just simply no change. Why? Because you probably remember that we just mentioned that when we loaded this table into the in-memory, the data has been compressed. So in order to calculate the standard deviation, they actually, for every row, they actually have to uncompress the like say, for example, your each employee the salary. So those salary, when the salary table load into in-memory, everyone's salary was compressed. But to meet this standard deviation, they actually have to uncompress each employee salary and do calculation, like a comparison or calculation with your average. So that means every row they have to uncompress your data and to do calculation. So that's very time consuming. But if you're not using in-memory, the data by default is not compressed. You just simply do calculation. And using in-memory, you actually have to uncompress. This take a lot of resource. That's why the in-memory, in this case, the majority of the problem is not how fast you can get the data from the disk. Is how much time you need to spend to do calculation. And in-memory, well, you have to uncompress and to do calculation for each row. For non-in-memory, you don't have to uncompress. That's why we end up in-memory actually take more time than not in-memory. So result is for this kind of standard deviation, probably in-memory doesn't help. Yeah, so that's the result we found. So that's pretty much all the content I want to cover. And again, if you have any question, I know we are recording this presentation. If you have any question about my presentation, you can contact me. This is my email address. You also can come to my blog to download this presentation, which I'm going to load probably today or tomorrow. And also, if you are interested about all other topic, so right now I'm listed. I already have 149 presentation already uploaded. You can feel free to come here to download my application. So my presentation, most of my presentation cover Oracle database, RAC, virtualization, cloud, some of Oracle e-business application. So yeah, feel free to come here. And I have been speaking in last 11 Oracle Open World and last 9 collaborative conference. So I'm going to in Open World 2015, I'm going to talk about how to upgrade your database to 12CR2. So it's going to be on Sunday session, October 1st. So hopefully see some of you at the Oracle Open World 2017. So that pretty much conclude my presentation. Thank you for taking your time to see my to attend my presentation, and hopefully see you next time. Thank you.